All right, we're back for part two. So now I want to get into slices, and slices are just how you access list or string data. So I'm just going to make an example list. For example, these are axes, so I can have x, y, z, w, 1, 2, 3. They are not just axes, but whatever. And this one, where when I just get one element from the list, it still doesn't work properly. Okay, too bad. And there are different ways you can do this. You can use -1 to get the last element. You can get -2 to get the second to last element, and so on. But what's more is you can take entire sections of the list. So you can specify a start, for example 0, that's going to be x, and an end, and that's going to be it's going to be one more. So if I put 3, I'm just going to get 0, 1, 2, and it's going to skip the 3. It's going to go until 3, not including 3. And if you leave out the start or the end, it's just going to go from the start or until the end of the list. So this would just this would be the entire list. And this would, starting at the index 2, that's z, we go for the remainder of the list.
And the first one where it has 0 column 3, you can also just have column 3 and then it's this x-axis.
Yeah, exactly. So this implies 0. And we can do like this, and then we really do something more meaningful because it's now 1. There's yeah, you can even use the minus as a start. So if I go -3 and then until the end of the list, I go from 1 to 3. And if I do, until the second or until the last item, I just get the list minus the last thing. So this is a really clever way that you can not only use minus signs to go from the end of the list, but also use colons to indicate a start and an end. But you can also specify a step size. So I can go from 0 to 4, taking steps of 2. And it's going to be 0, and then skip, because we're taking steps of 2, and then it's going to be 2. And then it's going to be skip, and then it's until 4, so we're also going to stop right there. And that just gives us x and z. But if we start at a 1, then it's going to give us y and w. And that's a really powerful thing. And again, because these things are kind of implicit, if I leave it off, it's going to be a 1. So this is the same as this, and it's the same as this. And this is the same as this, and this is going to go until the end. So you can sometimes see this, where it doesn't specify a start and a stop, but only a step size. So it's going to grab the entire list, but taking steps of 2.
This can be super powerful because you don't even need to know how big the list is. You can just split it in.
Exactly. So if I start at a 1, then I'm going to get all the other items. So I get like even and odd as 2 separate lists, and I don't care how big this list is. It's just going to be split into 2 lists. One is even, one is odd. Oh yeah, one other crazy thing you can do is if you put -1 as the step size, it's going to reverse the list.
There are also functions for this, but slicing is just easier to write out quickly.
Yeah, I think you can just put reverse, and then you get a reversed. You get a reverse object, or list reverse iterator object. So you convert that to a list again. It's this makes it more readable, this makes it less readable. So very often you see this instead of this. They do exactly the same thing. So all of this works with string data as well. So I could just put w1 to 3. Then 1 to 3 are not numbers, but they are single character strings. But all of this will still hold up. So if I take, for example, this or this one, or the reverse, you can just reverse text in the same way.
Note that you now don't get a list back, but you actually get the string as a whole back based on that information.
So even if I do the every odd or even character, this is now a string, so I can print the type of that. And then it will tell us that that is string data and not a list. Whereas if I go back and do it like this, it will be a list because I started with a list. Yeah, there's another cool utility that I want to share, but that's more something that you should probably keep somewhere, copy paste it somewhere else, and just make a function with a def, and then it's like I usually call this replace, but you can also call it replace write or replace from write, and then you can put in text, you can search, you can replace, and you can have a maximum replacements. Is that how you do it? I think so. Let's leave this one away for now. So normal text has a replace function, and you can search and replace, given that these would be variables. So my text is hello world. I'm going to search for world, and I'm going to replace it with earth. Then normal text can do a replace from the left, and we can replace from the right by reversing all of these strings before doing anything. So text is going to be the reverse of text, and all of this is the same. So search is going to be reversed, replace is going to be reversed, and then this code is going to be the same where we do a normal replace. But then that result is also going to be reversed, and then we'll return that. And we do need this extra argument, so this is the max things to replace. I forgot to show that in the string section earlier. So if I have 3 times world, I can replace only the first 2 occurrences of world. So let me just quickly display that. So it's finding one world's going to be Earth, second world's going to be Earth, and then it stops because we said only do 2, and we can only do 1 as well. And it's only going to replace the first one. But if you only want to get the last one, that's when you can make this function, which really just type it over and save it somewhere, because it makes no sense that this is not a part of Python already, and it's a really weird trick to remember, at least to me. So I just have it somewhere in the utilities file, and I just use it whenever I need it, without ever actually remembering how to write all of this code. So now it replaces the last instance. I think that's really powerful.
Also in this case, you might want to talk about giving a default value to the max things to replace, so that people can already get used to that.
Oh yeah, that's a good one. Yeah, I'm not really sure how you can do replace all, but you can put like equals and you say always only replace 1 by default. And then if you don't put that here, it will, so if I specify it, it's going to use my version. But if I don't specify it, it's going to use the version that you specified when you wrote the original function. So like this, it will also work, and it will also just do 1. But I can choose to do 2. And then that's like an optional extra argument that I can put in between these brackets, but I can just leave it away and it will still work because there is a default value to fall back on. If I don't do that, you get an error. So to demonstrate that, it says you need to put 4 things and you only gave 3. So that's all the most dry and boring Python stuff. And now we can actually get back into some Maya, but it's going to be a little bit more boring stuff, I'm afraid to say. So what I really want to show is if you have a structure like this, and I'm going to hide my shapes, where you have 2 groups with 2 objects in there with the same name, then Maya functions start to break down. So if I import cmds and I say cmds.getAttr eq1.translatex, it needs to be capital A, then that will be an error, or it better be an error. It is not an error. What?
think they changed it.
Oh, cool.
But you normally would expect one single value.
Yeah.
And now you get a list of values.
It's still gonna break all of your code because getAttr is supposed to return one single number, like this one, and not a list. But that's interesting. That wasn't the case one Maya version ago, I believe.
Around 2018. Yeah.
I've been doing this for too long. I didn't know this was a thing, and we're on what, 2020?
Well, you could also do like something, maybe an XForm check. Maybe now you do the getAttr, so you use XForm, and then you grab the world space, the matrix information or translation.
I can just get the translation. That, yeah.
Yes.
Oh, no. Different error. I don't remember the long names.
Yeah.
There. That used to be the case with getAttr as well. Of course, they only changed getAttr and not all of it.
Well, getAttr is one of the functions that you can actually see in when you use the functions in Maya.
Mm-hmm.
And XForm is one of the extra functions that you actually need to search for because it has a lot more power under the hood.
Yeah, true. But I think it's sad that they don't do a uniform fix like this for everything. It's still broken in some cases, which means that we still have to deal with this problem. And there is a way to address objects by their unique name, and that's by specifying their parent name as well. And the way to do that in Maya is, you can already see it when I select this guy, it's giving me this 2 cubes with this bar in between. And if you ever want to get, for example, the selection with ls, you also specify long, and then you get the full name of the object.
But I think if you don't specify long in this case, you would still get the full name of the object because it's
you get a unique name, but the difference between the two is that this one doesn't start with a pipe and this one does. So this one shows that this is really the root of the scene. pcube2 doesn't have a parent. Here we are not sure about that. And that's why I prefer to always use long. Also because it's going to be very consistent. We can always rely on the fact that there's this bar in front of it. And similarly, there's a function called listRelatives, which I'm not sure if I've shown before. But it has 2 modes where you can say parent equals true and then full path equals true. Or you can do children. And those are the most common ones. There's a lot more you can do with it if you check the documentation. For example, if I select this pcube2 and then I run that...
CNDS.
Of course, I can't type.
Children.
If I run it like this, then I get the cube, and I also get the model that is the mesh that we're looking at here. So if you, in the outliner, you can display shapes, and you'll see those appear as well. So if you're ever confused by that, they're just hidden by default in the outliner, but they are objects in the scene. And the other way around, if I select that cube, I can go to its parent, and it will give me that bar in front of the parent name. And these are the most common functions that you use to navigate the scene. You get selection, you get parents, you get children, and this is how you get them to output full path names. Which, it complicates your code a little bit, because now you have to deal with this. But it is way more robust, it's way more reliable. If you have a script that creates a node, then parents the node somewhere else, and then renames it, and then that name already exists in the scene, and you don't expect that, then your script will break. But if you always use this, then your script will always work.
So this will not only take into account the translates and the shapes that you can see in your outliner, this will also work with the objects that are invisible in the outliner. So if you go to display and then DAG objects only and turn that off, you can see that there's a lot more information in your outliner. Those are called depend nodes, while the other ones are called DAG nodes. And the depend nodes don't really have parenting going on. So
yeah, so these don't work on that. But ls will give you just a long name, which I think is just the short name actually. And by not having a pipe in front of it, we can now check that it's a depend node instead of a DAG node. So this can have parents, this cannot have parents.
So if you now select the listRelatives and try to find the parent of the stroke globals,
it should give an error or just give none. Okay.
Or in some cases it's none or an empty list.
Right, yeah. Let's see. So if I get the parent of this one, it's also none. But that's fine. I mean, that means your code won't break when you're using these functions and the selection accidentally doesn't contain a DAG node.
Exactly.
Yeah. So yeah, this gets more complicated as we start manipulating the scene. So for example, I can create a cube now, and this is my cube 1. I can create another cube, cube 2, and I can parent cube 1 to cube 2, and that is going to return something. Now I'll show you. If I run these 3 cubes, or these 3 commands, the cubes get parented, and the last one will actually give me the name of the cube. But if this was going to create a naming conflict, then it would give me a unique value, which would be like p cube 5 and then a pipe and p cube 4. But to be 100% safe, what you can do is actually call ls long equals true on this parent command. Let me just undo this so they're not parented. And then I run this command. And now our result is going to be the full name again. And this is me basically doing due diligence, where I just want to make sure I always have a long name whenever I deal with names, because it's safer and it avoids naming conflicts. And this is kind of what I do a lot in my code, or I write small functions that will help me do this. Similarly with rename. So if I rename pcube4 to pcube1, and I'm using the short name, that will work now because it's, it's not a naming conflict. There's only one pcube4, but then it's going to return the new name, which is going to be pcube5 by pcube1, because that's the unique way to get to that name. And then again, you can, if I undo this, you can do the same trick where you also use ls long equals true to get the, so this is cube 2, no, cube 1. Now I run this, and now my cube 1 variable gets updated. It's pointing to the same cube, but with the new name. And that's also a risk that you have to consider when you're parenting and renaming. You might suddenly create the situation where your name is no longer unique, or your name is simply outdated. Because my old cube 1 variable was pcube4, that object doesn't exist. So now if I run code with this variable, and I forgot to update it after renaming, we're in this whole world of trouble where our code suddenly breaks because it changed the name. And what's worse, even if you hard code it, this might not be the name you get. So if I create a new cube, it's going to be cube 5 or cube 6, and I parent that to cube 5, then it's still cube 6, and then I try and rename this result 0, because result is a list. Let me print it for you. So that's 6 parented under 5. I'm going to rename that to cube 1. It's just going to do it, but it realized that cube 1 already exists. So pcube5 cube 1 is already a thing that's there. So if I do this in the outliner as well, that doesn't work. It just renames it to the next cube. So that's 5, 6. If I change this to 7, it's still going to rename to 8. But I changed this to 7, so now my variable is out of date. And that's also, when you're using code, you have to do everything in code, because now I use the UI and now all my variables are outdated. But I'm just going to demonstrate this real quick, where I just rename pcube7 pcube6 to be pcube1, and now it's 8. And rename returns to me it's pcube8, and then ls makes that the long name, so I actually get the full path to that object. So it's still pointing to the same cube because I go through all this extra effort.
So what you should do here in code is try to minimize the amount of exact values that you get in there, and let Python return the results that you need and that you can work on later. Because if you are going to think of everything to be like this, the final result, if there's one naming change in there, the entire code does not work.
Yeah, and what's scarier is if you're operating in a user's file and they already have an object name that you think you're going to create. So sometimes you see code like this where it's just, I'm going to create a polycube, then I'm going to rename pcube1 to my cube. In a new scene, this would work. But since in my scene I already have a pcube1, this polycube is going to give it a different name. And now your code is going to mess with my scene instead of with the thing you thought you created. So you always want to use a variable name. And you always want to use that variable name when giving it to rename or parent or whatever. And then if I already had a my cube in my scene, then this would still not work, right? So then I also always want to update what comes out of there. So I create a new cube, I use the variable name, and then that has a conflict or not.
Because it returns.
It's a list, okay. I put 0. And then I run this. And then that's my cube 1, contrary to what you specified, but that's fine, right? You're using variables, and your variable is now pointing to my cube 1.
One extra side note here, almost all the creation tools in Maya have a name variable in there. So you could do name equals my cube, and you already get like whatever specified name you get. But also this one would automatically just give you the updated name back.
Yeah. Yeah, and this returns like polycube because that has like the width and the height and the depth in there. And we usually don't use that, so you can immediately do it like this, and then you just get a new cube and a variable that has the name of your new cube, regardless of what Maya had to do to make this work.
So one of them is the actual transform that holds the shape, and the other one is actually the creation node for that cube that gives all the data on how to build the cube in Maya.
Yeah, and then I would still want to use ls and then long equals true and then 0 again to get the full name, just for safety. Basically, when you're running your own code, you don't necessarily need to constantly do this, but when there is a moment where the user gains control of the scene and can change stuff, or when your code is actually parenting and grouping items, that's before and after parenting and grouping is when you want to make sure that all your variables are using long names, just in case that group creates a naming conflict and you had a variable with a short name that is now illegal or pointing to multiple objects. So that's there are cases where you don't have to do this and you get away with it, but I prefer to just always do it until you know what you're doing, because this is going to make your code 10 times more robust and decrease the likelihood that you ruin someone else's scene with your script. So I think that's all the dry stuff I wanted to cover. I think we've also been going on for quite a while. So yeah, I'll do a demonstration of this next time where we put all this together with the strings and the slices and these full path name rules, where I also demonstrate some problems which can occur when you're not using the full path names. But yeah, that will be for next time. Unless you want to add something.
I think we covered most of it.
Yeah, it's it's a lot of dry info. I'm sorry about that. But this is a huge setup where we can immediately start playing with renaming tools next. So that will hopefully be very cool. I hope you learned something, and thanks for joining.